I'm Patrick Bailey with IQlist.com. Today is April 24th, 2018, and this is Manipulative Monday. And this Manipulative Monday, we're doing a follow-up on the last Manipulative Monday we did on shapes. Now, in our last Manipulative Monday, the challenge was shapes. So kids age 7 to 11 could learn their shapes. Now, so far, that video actually, as of today, that video hasn't actually gone out yet, so I don't have anybody else who's actually taken up that challenge yet because the video hasn't gone out. But be sure if anyone, but just know this, if anyone has actually taken up that challenge, yeah, I'll post any anybody who takes up the challenge and makes something neat, I'll definitely add that in the next video that we do for the Manipulative Monday. Because boy, I want more people to take on these challenges and make some cool stuff. But anyway, in Tinkercad, in our Manipulative Monday on shapes, we figured out a good way to do the shapes was to use Tinkercad. And to use Tinkercad to make the shapes and do an interactive with the kids so that they could actually use Tinkercad, put the shapes on there, download the STL files and watch them get created. So it's a whole really cool process to do all together. But we did notice, my wife did have a couple of complaints that most of the shapes were great, but a couple of shapes, especially the cylinder here, it could be a slightly confusing because it's not a perfect circle. So if you looked at this, I actually counted it. It actually has 20 sides, which is okay, but it's probably better to get it more circular. Now, turns out there's a way to do that in Tinkercad, which I'll go over here in a bit. So I want to make that and also make a cone more circular. Also, I was going to go over in this video how to make a tetrahedron, which I can't find one on Tinkercad right now, so I'm going to show you how to make one in Fusion 360. I'll also provide a link to it because you can actually download an STL file and upload it. So with that, let me get going and show you how to get more circular cylinders in Tinkercad. Okay, now in Tinkercad, how can you make your cylinder more circular? Well, it turns out it's a little easier than I thought, even though there's two ways of doing it. A lot of these tools, all these basic shapes, let me go back to basic shapes, sorry. A lot of these basic shapes, if you click on them, you'll see they actually have some extra little sliders and tools that go with them. Now, as we printed this guy out, it turned out it had 20 sides. So it doesn't make a perfect circle, but it kind of angles around and gets approximately to a circle. Well, it turns out you can increase the number of sides. So over here, I can actually slide this over. And let me zoom in so you can see a little better. And watch. So we go from 20 to 25, 30, and this goes all the way to 64. So it gets pretty close to approximating a circle. There we go. Okay, and so you can get it to 64. So that is the way to make it more circular. That's a simple way. And I can also do the same thing with cones. So when I did the cone last time, I didn't realize this tool was here. Let me make a cone on this guy. So we'll do 70 by 70 and 70. I'll replicate the cone we had last time. Here on this tool, there also is sides. So currently it's 24. And so if I zoom in here, you can see I can start editing this and start making it, or I can make it less. So watch, it gets really triangular. And I can, again, go up to 64. And so that gets a lot more approximately what it should be as a cylinder. Although we weren't complaining too much about the cone because it's pretty obviously it's a cone, but anyway, it should be. I'm going to go print both of these out and see how much smoother they compare to what we did before. But also, there actually is an even smoother cylinder you can do in here. So if you go click on the basic shapes area, you can actually go down here, and it turns out there's a shape generator. I believe there's a bunch of shapes out there, and I think you can actually code this, so don't quote me on this, but I think you can actually go in here, and if you know some JavaScript and stuff, you can actually write some code that will help people generate shapes. And other people have already done some of that. So I can actually go down here and click on all and find other people's shape generators they've made. And now down here I found one that is for cylinders that happens to have more than 64 segments. So, oh, there it is, cylinder. So if I drag this guy out here, and we'll do 70, 70, and 70, right? So this similarly has tools, but you can look, if I click on this, the tools are a little different. It's got a few different sliders because someone custom made this. So I can go here, and rather than do divisions of 20, this one actually goes all the way to 100. Boom. So that should be a much, much finer circle, much more accurate. So I want to go print both of them and see what the difference really is. I mean, 64 might be more than enough, but it's nice to know you could do 100. And if you could do 100, why not do 100? I mean, you're the one printing it out, right? So let me go do a comparison. Let me go export each one of these. So I'll click on that one, click on export, and hit STL. And now as it exports that, there we go, did this earlier, it goes to my downloads folder, but it names that file after this entire thing, which I just called cylinder fat in my case. But I want to change the name, so cylinder 100 sides. Oh, if I can spell sides. So let me click on this one, export it, click the STL button. Now it should be here, but again, I want to rename it so I can keep track of these better. And do 64 sides. And then the same thing for the cone. But in the case of the cone, it's called cylinder, which is a little confusing. So I'll say cone 64 sides. Oh, not 64 sides. 64 sides. So there's our 3 files that I would like to redo. So let me take those aside and go find, come on. There you go. The Prusa control. So I'll just take the Prusa control as my slicer. And I'll start dropping these in. So there is my cylinder. You can see it's a lot finer. In fact, let me go open up another location. Let me go open up my old one just to show you the difference. Okay, where are you? 3 prints. Gotta get a little more organized some days, right? Shapes. Cone. Okay, here's the cone I had prior. A lot more detail, right? So I'll erase that one right now, and so I'll generate this. So I'll make it 0.2 millimeters per layer, because this can go fast. It's not going to be, you don't need, it's fine being not 0.2 millimeters. And sparse, we don't need it that full, so 10% is more than enough. And so we'll just generate this. And there we go. Looks like it should do a much better job. So let me save this G code. And for the moment, I'll just save it in my downloads folder again, just for the moment. Let me go back. Delete this guy. And let me drop in that 64 sided. So there's my 64 sided. And let me go grab the original one. You can see there's a big difference there. So let me delete that one. And let's generate this one. Same thing, 0.2 millimeters layer and 10% for the infill. Let's do generate. And look at that. And save the G code to the downloads again. Okay, let me go back, delete this file, and let me look at the 100-sided. Wow, that's much, much more detailed. If I compare it to the old, yeah, totally different. Totally different. Okay, so there we go. And same thing, 0.2 millimeter for the layer height, 10% infill, and just click generate. There we go. So let me look. Looks good. Okay, let me save that G code. Okay, so with that, let's go print those out and see what they do and what the difference really is now that we've got more sides. Okay, first I always want to go over the numbers. So I printed all these out. And so I have the orange here, that's a 64-sided cylinder, and it took 2 hours and 53 minutes to print. It took 2.4 cents worth of electricity, based on 10 cents per kilowatt, and it weighed 0.056 kilograms, so at $20 per kilogram for a roll of filament, that comes out to $1.12. So all in all, this cost $1.14 to print. And then I have my 100-sided cylinder, here in white, and it took 2 hours and 52 minutes to print. It took 2.4 cents worth of electricity, and it weighs 0.058 kilograms, which comes out to $1.18 for the filament alone. So altogether, this cost about $1.20 to print. And then I have my cone that has 64.
Hold on.
What?
So this took 1 minute less.
Yes.
And 5 cents more.
Yeah, the numbers aren't perfectly accurate. You know, there's a little bit of error in there.
Yeah, there's always a plus and minus, but...
they could have, yeah.
Now, okay, I'll let you finish, and then I have questions.
Okay. And then I have a cone that has 64 sides, and so this took 2 hours and 15 minutes to print out, took 1.7 cents worth of electricity, and it weighs 0.02 kilograms. And so on all, this came out to 41 cents to print this guy out, which is similar to what the cost to print out the 20-sided one. So now we can get your opinion in after you show us some images. So
okay, so what was the difference between? First of all, I think these look great. Much. So there's the 20-sided. There's the 64. I don't know if you can see the reflection. It has a little bit of a flat facade. And then there's the 100, which, for a kid, you're not going to notice.
No.
So my question, if there's really no difference between printing this, the 100 facade, and the 64 facade, I would say print the 100.
Yeah.
The question is, what's the difference in cost between this and the 20?
So nothing. I have to go pull it up. But yeah, you're talking, I'd have to go.
Insignificant?
You're going to make me pull it up, aren't you?
Insignificant because at least this is not confusing to those early learners. Like this could be confusing with all of its flat sides.
$1.14 is what this costs $1.14.
And this costs $1.18?
$1.20.
20.
And there's a margin of error in there. So they could actually be the exact, you're talking 6 cents.
Cool. I really like this one, this 100-sided one. And I realize I'm sure it has 100 sides, and I'm not going to sit here and count them. And if I really pay attention, I could probably see them. But I'm not going to pay attention. With this one, which is 64-sided, you can when you rotate it, the light shines on it a certain way, and so you can see the flat facades, but
I don't think the 64 side. I mean, I understand that this could confuse a kid.
Yeah, I don't think this would.
But a 64 side, I don't think is going to confuse a kid.
Not at all.
And I don't think, like, here's the regular cone that has, I forget, was it 20 sides? I forget how many sides this has. The regular cone, I don't think that confuses a kid. Not really, right?
Yeah.
But you might as well make, 64 side, because there's really no difference. Right?
Well,
I mean, it looks better.
You want to try and negate all the variables. So, if you have an early learner, get as many of those.
Yeah, where that could confuse a little kiddo.
Yep.
A little bit. So you might as well do that.
Well, thanks for fixing my question for me.
Well,
now we have 3 more blocks to play with.
Now you got more blocks.
More blocks. Look at, now we have 2 cones that go together. By the way, since you have printed these out, I purposely have put them down on our coffee table in the living room just to see what would happen.
And so what's happened?
Oh, people just play with them.
Is your mom playing with them?
She picks them up and fiddles with them, yeah.
Yeah.
But it's hard not to just be like, oh, cool. First of all, it's 3D printed, so you just kind of want to go
touch them, yeah.
And then, and you're like, oh, well, I wonder if that fits on that. And, oh, that's so cool. And then you just start, whether you kind of know what you're doing or not, it just kind of makes it fun.
Okay.
Thanks, honey.
Well, cool. Well, there's that. Okay, now on to Fusion 360 and how I made the 3-sided pyramid, which is also called a tetrahedron. Now, for those of you who may not really want to get into Fusion 360, or at least not right now, I think it's a great tool and worth learning. But if you just want the tetrahedron, there's a really easy way to do this. So what you can do is I actually posted the tetrahedron I created on Thingiverse, and it happens to be thing, what are we at? 2877616. So you can actually go to this URL and then just download this file. So you download this STL file. Oh, well, I don't like to download the files. I usually click on the thing files and download the individual file. So let me just download the individual file. Blah, 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 blah. And go to my downloads and oh, there it is. So now, there it is. So now I got the tetrahedron file. I downloaded it from Thingiverse just like anyone can do. And the nice thing is if you go into Tinkercad, you can actually import STL files into Tinkercad, which is really cool. So pretty much anything you find on Thingiverse, you can import into Tinkercad. Now I think sometimes it does dumb it down a little bit depending on what the shape is. So I don't know how perfect. I haven't tried to do anything complex. Let me go over here and click import and then choose a file. So I will be real simple about this. I will just drag this tetrahedron right there. See the color changes red. And there it is. So there's my scale, my dimensions, my height, and just hit import. Boom. And it'll go through its process. And then there it is. So there is my tetrahedron. So simple as that. If that's all you want, if you just want the tetrahedron, you are done. In fact, after you have it, you can sit here and it's not stuck. Let me get rid of this so I can maneuver. You're free to resize it. So I can click on here and if I don't like the size, I think I accidentally changed the size while I was moving around. You're free to change it. So you import the STL file and you're free to tweak it. Now, on to how did I do it in Fusion 360. So in Fusion 360, if I can get you to come over here, there we go. One thing you may want to be made aware of in Fusion 360 is I had to change my ZX axis, or the way I work is I kind of want it to match the build plate on my 3D printer, and on my build plate my Z axis is up. So you look over here on the right, you'll see I have my Z axis up, but that's not normally how it's set. If yours is not set that way, you can easily change it. So you can go up here to your name, go to your preferences, and you can see right here, default modeling orientation. And normally it's Y up. You can actually change it to Z up and hit apply or OK. And the last time I did it, it didn't actually apply right then and there. I actually had to restart Fusion 360 to see the changes take place. But I think that makes it easier because now I can think of this as my build plate and design correctly that way, rather than design it and then have to move it 90 degrees. Because whatever I want to upload to Thingiverse, I don't want people to have to rotate it. Okay, so let's get started. So what we want to do is, first of all, do some good practice in Fusion 360. Click on here and do new component. And I'll click on here and call it tetrahedron. Tetrahedron. Hopefully I spelled that right. And click on here and turn on that light bulb so now I can see these origin planes. And what I want to do is I want to draw the equilateral triangle on the ground and have it be extruded up. So what I'll do is I'll right click on here and say create a sketch. And so now it moves over into this plane, and now I can start sketching on this plane. And then I can hit L for line. So now I got my line tool, and I'll tie it right down here to the origin. I'll start dragging it over here, and I want it to be 70 millimeters. So I could put it at 70, or what I can actually do here is I can just type 70 and hit enter. Boom, I got my line. So that's my first line. Now the next thing I want to do is this needs to be an equilateral triangle. So there's a couple of ways of doing that. What I'm going to do is I'm going to make like a helper line for myself right now. So I'll hit the L key again, and I'm just going to draw an arbitrary line. I don't really care what it is. I just want it to be 90 degrees parallel to this line. So I'll make that line, hit escape, and then what I'm going to do is I'm going to put a constraint on this. So I want this little dot here to be at the midpoint of this other line. So I'll go over here and click on midpoint. I'll click on that dot and then click on this line. Boom. So now it's in the middle of that. And then what I want to do is I'm going to have the other lines arc up to hit that. And this line actually, I need to do a dimension here. So this line right here should be 70 millimeters tall. No, that's wrong. Oh, I'm saying that wrong. So I want all sides to be equal. So they're going to have to hit there. Let me hit the L line key again. So I'll click on here, come up here, and I can hit the tab key, And I know this should be 60 degrees because it's an equilateral triangle. So 60 degrees, hit tab, and you see that's locked in now. And so now I can just go up, boom, and specify that point. Hit escape, hit this, and raise this up a little bit. There we go, so we got our line. And now I'll come over here and hit the L key again, start here, come back. And I know that angle is supposed to be 60 degrees too as well, but in this case I'd have to do 90 plus 60. And it turns out in Fusion 360 you actually can do math in here. So I can do 90 plus 60, hit enter, oh, 90, oh, well 60 degrees off of there, so that should be 30, right? 90 plus, oh, because, oh, I'm thinking of the wrong angle. 90 plus 30, duh. Enter, there we go. Oh, and I should have extended that. I shouldn't have stopped that. Let me undo that. Line, there we go. Okay, so back to the angle. I'm going a little too fast here. So another thing I could do is I could do 180 degrees minus 60. And then hit tab, that locks that in, and then go up here to where they meet, and click, and there we go. So I have my equilateral triangle. Yay! So now I can hit stop sketch, and go here and click home, and now I can see I got an equilateral triangle for my base. But I want to extrude it. So what I can do is I can press Q for my press pull tool, and I can select that, hit the shift key and select that, and so now I've got all that triangle. If I do that, that just makes an equilateral triangle. But what I can do is I can actually taper it. And what I did is I could probably go do some research and see what the angle should be, but I'm a little lazy about this because I'm not exactly sure how the taper angle works. So I just kind of did some tweaks. So I did 10, which actually goes out, which means I want it inside, so I'll go negative 10. And I want this to be 70 millimeters tall. And so based on that, that taper is not enough. So I can go, this is what I did last time. I went 15, not quite enough. 16, looks like 16 is about right. Oops, if I got a little divot there, right? So I went 16.1, I think is what I did last time. Boom, that looks good enough for me. Okay, so 16.1, tapering that in, and hit OK. And now I've got my equilateral triangle. So I can look around there. I mean, my tetrahedron. So now I've got my tetrahedron. So that's all I did. And then from there, if in Fusion 360, I can create an STL file. So I can come up here and click Make, 3D Print, select an object, this object, and then I don't want to send it to MeshMaker, I just want the STL file. So I'll uncheckbox that, hit OK, and I'll put this on my desktop and just call it tetrahedron. Hedron, if I can spell. Okay, and save that off. And now I've got my STL file that I can drop into Prusa Control and slice it and print it out. So that is how I quickly and easily made the tetrahedron. So it's interesting to know if you want to try to figure that out in Fusion 360. But if all you need is a tetrahedron, just go download it. I mean, go pull it off Thingiverse. And I'm sure I'm not the only tetrahedron on Thingiverse. But it's really nice to know that you can download any STL file from Thingiverse and you can actually import them into Tinkercad, which is just, that's a really cool thing that you can do. Anyway, so that's enough for this video, I think. Hey, if you liked the video, please give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we were doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.